All right, in this video, we're actually going to measure the angles and the side lengths to figure these out. So on ALEKS, there is a ruler tool that you will click on and it will actually let you measure on ALEKS. So first, we're going to use the triangle angle sum theorem to find any missing angles because usually they give us 2 out of the 3 for one of the triangles. And then we're going to use the ruler on the next page and we can cut one out if we need to, or if you're using it on ALEKS, you can always just use the one on ALEKS on the screen, of course. And then finally, you're going to use those measurements to answer the following questions. So let's go ahead and take a look at those. So here are all the questions they want us to answer. So they gave us these pieces here. So they told us that angle A was 30 degrees and angle B was 75. Angle D is 30 degrees and angle E is 75 degrees. So they gave us these 4 pieces of information. So they want us to answer the question, what is angle C and what is the measure of angle F? So we're going to have to use the triangle angle sum theorem to answer this, because the 3 angles of a triangle have to add up to 180 degrees. So 75 plus 30 plus angle C equals 180. So then I'm going to add my like terms together here. And this is also going to be the same for angle F because it's 75 plus 30 plus angle F, right? So 75 plus 30 plus angle F would also be 180 degrees. So really, I don't need to do this twice. I could just do it once, and it's going to be the same for both. So 75 plus 30 equals 105, plus angle F equals 180. I'm going to subtract 105 from both sides because that's going to tell me what's left over of the 180 for either angle F or angle C. Remember, they're both going to have the same result here. So angle F and angle C have to be 75 degrees. So I've answered part A. Now I'm going to answer part B, and they've already told me which ones they want me to grab. So they say do AB first, then DE, then BC. So they want me to get all the all the side lengths. So I'm literally going to have a ruler, and I'm going to set it up. Make sure that you set up the 0 line here and that you read it down here. So this one looks like it is 40 millimeters. And I'm doing this in millimeters because that's the ruler that came up on ALEKS. So I'm trying to make this match kind of as closely as I can to that one. And then the next one here that I'm going to do BC, so I'm kind of going across the top here. So BC, again, I'm going to line it up here, and then I'm going to read it from this mark. So that's 20. And then I'm going to do CA. So again, I'm going to line it up on one of the corners and then read it down at the bottom. So that one also is 40. All right, now I'm going to flip over and I'm going to do the little triangle here. So I'll do DE. So I have it lined up, and I'm going to read it right here. So this one's a little different. I might need to count the tick marks here. So with this one, I end up with 14 because I end up with 1, 2, 3, 4. So make sure you're being very exact with this one. If you're kind of rounding or about close enough, you might not end up with quite the right ratios. So be very exact when you're doing this. So then EF, I end up with this one. So if I read on this one, I end up with 7. If I count all of these, I end up with 7 tick marks here. So each one is worth 1. And then same thing, FD, if I do this one, it looks like I end up with 14 again. Okay. So now we're going to put them into ratios. All right, so when I put this into a fraction, remember AB was 40 and DE was 14, but I want to reduce this because they can both divide by 2. So if I do 40 divided by 2, I get 20, and 14 divided by 2, I get 7. And that kind of should scooch down there. The 7's just getting cut off a little by the line. BC over EF, well, 20 over 7, that's already reduced, and it's in fact matching, so that's okay. And then CA over FD, that's 40 over 14 again. So we would simply just divide by 2, again, to get 20 over 7. Looks like I just need to scooch my 7s down on all of these so that we can see them. So now we can see that all of the angles are congruent, so they're at least similar. And then we can see that the side lengths are all proportional. That's what that means when we get the same ratio for each side length. So you're just going to choose, and there's 3 groups here, so you're going to choose 1 from this group, 1 from this group, and 1 from this group. So 3 pairs of statements are shown below. For each pair, select the true statement. So you're going to end up selecting 3 things. So the angles in ABC have the same measure in the angles in DEF, or they do not. Well, they do, so we're going to select that first one. And then the ratios of the corresponding side lengths are all equal to each other, or they are not. Well, they are. They're all 20 over 7. And so since we have both of these highlighted as they the angle measures are congruent and the ratios are the same, the triangles are similar. So this is kind of the idea of when you're going through and you're proving similar triangles. I hope that helped, and I'll see you in the next video.